Hey YouTube, this is a demonstration of the XF-119SN filter, which is Yaesu's part number for the Collins 526-8739-010. This is a mechanical filter with a center frequency of 455 kHz and a bandwidth of 2.3 kHz, and is intended to narrow a transceiver's bandwidth to optimize single sideband, or SSB, reception. Collins discontinued the production of these filters in the late 2010s, so they have become relatively difficult to find, but I was able to find one from a private seller for a reasonable enough price to where it piqued my curiosity. I'm installing this one in a Yaesu FT897D that I primarily use as a base station. I'm currently using it through a Yaesu XF-119SN, which is mounted outside on my roof and allows me to optimize the tuning for multiple bands from the face of the radio. This setup actually works pretty well for my needs, though I live in an area with heavy amounts of RF interference, so it is not uncommon for me to have a noise floor around S9. My hope was that the filter would allow me to pull signals out of this high noise floor, perhaps with the additional help of the 897D's attenuator and DSP as needed. To install the filter, I ensured that the transceiver's power was off and disconnected from the power supply. I removed these 8 Phillips head screws, carefully removed the top cover, made sure to disconnect the speaker's delicate connector at the corner of the main board, and set it aside. One end of the board has 3 holes, and the other end has 4 holes, which correspond to the number and orientation of pegs on the areas marked FIL1 and FIL2. In this case, I installed it into FIL1 by carefully aligning the slots and gently pushing down on the filter squarely to ensure that it is seated. Once installed, the filter can be selected using multifunction row N. The following audio samples were captured via a DigiRig mobile interface and recorded directly into QuickTime without any editing or modification. In other words, this is the raw output from the radio. You will hear how the sound quality differs between the stock ceramic filter, marked as C-Fill, and the mechanical filter, marked as 2.3. I also toggle the attenuator and DSP noise reduction on and off to compare each of their effect on the final output. Overall, I am happy to hear that there is actually a difference and that it does really seem to help clarify signals, or at least to my ear. I'm looking forward to see how it works in practice going forward.
Gotcha. And you're 5 and 7 in Georgia. Thanks for the call from North Carolina, and thank you for hunting 73. AB4KM, 6 photo. I think I have that right. Kilo Quebec 4, November Hotel Yankee. Is that right, Brandon? 5 and 9.
That's correct.
Roger, you're 5-9 in my 2 parks in Georgia.
You're 5-9, 73.
Thanks for the 5-9 from Florida and 73. Good luck hunting. AB4KM, 6 photo. Kilo 8, Whiskey Lima, Kilo. Hello, William, 5 and 9, Georgia. Roger, you as well, and thank you for hunting me out here and being part of the fun. And 73, AB4KM, 60 photo. Kilo Quebec 4, Yankee Romeo Lima. Hello, Michael, 5 and 9 from Lehigh Acres. Good morning. Roger, I'm getting mixed up on when I stopped a while, maybe I said, good morning. Okay, got to switch now. Yeah, I used to live in Immokalee back in the dinosaur age. So, yeah, I remember Lehigh Acres. And thank you for the call, and good luck hunting today.
Really only going to hear down to 60 hertz with a pair of headsets on, obviously you can hear a little bit lower if they're sensitive enough, but he said get it out of there. You don't even want it because all it does is create rumble.
Your ear can't hear below 40 hertz. You can feel it, but you can't hear it. My EQs are all, I always set them to either 50 or 60. 60 is the go spot for audio for me. It's just because I don't want it so deep that people can't hear it. Now, bear in mind, most radios out there, they're not receiving below 50 hertz. They cut it off right there at that point. And most of them can't hear below 100 hertz, the older radios, so if you put too much energy and power and sound in below that,